Science explains why the sky is blue, and it's not what you think. Have you ever wondered why the sky is blue? It's a question that has puzzled humans for centuries. Many people think they know the answer, but the truth is actually more complex than you might imagine. The phenomenon of a blue sky is a result of light scattering and reflection off the Earth's atmosphere. In this video we'll delve into the science behind why the sky appears blue and why it changes color throughout the day. From the role of oxygen and nitrogen molecules in the atmosphere to the reasons behind the orange and red hues of a sunrise or sunset, we'll explore the fascinating science behind this everyday wonder. You'll be surprised to discover that the sky's blue color is not just a matter of aesthetics, but rather a result of the laws of physics. 1. The history of the question, why is the sky blue? For centuries, humans have been fascinated by the color of the sky. From poets to scientists, everyone has tried to unravel the mystery behind it. The question, why is the sky blue, has been asked for centuries, and the answer is much more complex than you might think. Greek philosopher Aristotle and Chinese philosopher Mozi were the first ones to propose explanations for the blue color of the sky. They believed that the sky was blue because of the reflection of the blue color of the ocean. However, this theory was later proven to be incorrect. It was not until the 19th century that scientists were able to provide a more accurate explanation for this phenomenon. In 1859, a Scottish physicist named James Clerk Maxwell proposed that the blue color of the sky was due to the scattering of sunlight by particles in the Earth's atmosphere. This theory was later proven by a series of experiments conducted by Lord Rayleigh, who demonstrated that the scattering of light by small molecules in the Earth's atmosphere was responsible for the blue color of the sky. This phenomenon is known as Rayleigh scattering. Today, scientists use a combination of physics and chemistry to explain why the sky is blue. The color of the sky changes throughout the day, and the different colors of light that we see at sunrise and sunset are due to the scattering of light by the Earth's atmosphere. The next time you look up at the sky, remember that there is a lot more to its color than meets the eye. 2. The common but wrong explanation. The common explanation for why the sky is blue is that the sky reflects the color of the ocean. While it's true that the ocean can appear blue, this is not the reason why the sky is blue. Another common misconception is that the sky is blue because it reflects the color of the greenery on the ground, but this is also false. In reality, the sky appears blue because of a process called Rayleigh scattering. This phenomenon occurs when sunlight enters the Earth's atmosphere and collides with molecules such as nitrogen and oxygen. These molecules scatter the sunlight in all directions, but the shorter blue wavelengths are scattered more easily than the longer red wavelengths. This means that the blue light is scattered in all directions and makes the sky appear blue to us. Interestingly, during sunrise and sunset, the sky can appear red or orange because the sun's light has to travel through more of the Earth's atmosphere. This causes the blue light to scatter in all directions, leaving behind the longer red wavelengths which are more visible to us. So, next time someone tells you the sky is blue because of the ocean, you can impress them with your knowledge of Rayleigh scattering. 3. The actual reason why the sky is blue, Rayleigh scattering. Have you ever wondered why the sky is blue? Well, it's not because the sky reflects the color of the ocean or anything else you may have heard. The actual reason why the sky is blue is due to a phenomenon known as Rayleigh scattering. Rayleigh scattering occurs when light interacts with particles in the atmosphere, such as nitrogen and oxygen molecules. When sunlight enters the Earth's atmosphere, it is scattered in all directions by these particles. The blue color of the sky is a result of shorter blue wavelengths being scattered more than other colors in the visible light spectrum. This is why the sky appears blue to our eyes. Interestingly, during sunrise and sunset, the sky appears to be a range of vibrant colors, such as orange, pink, and red. This is because the light has to travel further through the Earth's atmosphere during these times, causing more scattering and a shift in the color spectrum. In conclusion, the next time you look up at the sky and wonder why it's blue, remember that it's all due to Rayleigh scattering and the way that light interacts with the particles in our atmosphere. Science never ceases to amaze us with the wonders of our natural world. 4. How does Rayleigh scattering work? Rayleigh scattering is the reason why the sky appears blue to us. This phenomenon occurs when sunlight enters the Earth's atmosphere and interacts with the gas molecules and tiny particles present in it. These particles are much smaller than the wavelength of visible light, so the light waves can easily interact with them. When the light waves hit these particles, they get scattered in all directions. However, blue light waves get scattered much more than other colors because they have shorter wavelengths and are easily absorbed and re-emitted by the gas molecules in the atmosphere. As a result, the blue light waves scatter in all directions and fill the sky with a blue hue. This is why we see a blue sky during the day, especially when the sun is directly overhead. When the sun is closer to sunrise or sunset, the light travels a longer path through the atmosphere, resulting in the scattering of more colors and giving the sky a range of hues, from red and orange to pink and purple. Rayleigh scattering is also responsible for the color of other things we see in our daily lives, such as the blue color of the ocean, the blue tint of distant mountains, and the red color of sunsets. Understanding this phenomenon can help us appreciate the beauty of the natural world around us and the science behind it. 5. What is blue light and why does it scatter more? To understand why the sky appears blue, it is important to understand what blue light is and why it scatters more than other colors of light. Blue light is part of the visible light spectrum, which is made up of a range of colors that we can see with our eyes. These colors include red, orange, yellow, green, blue, indigo, and violet. When sunlight enters the Earth's atmosphere, it encounters a range of gases and particles. These particles, which are tiny molecules of oxygen and nitrogen, scatter the light in all directions. This scattering process is known as Rayleigh scattering. Blue light has a shorter wavelength than other colors of light, which means it is more easily scattered by these tiny particles in the atmosphere. As a result, when sunlight enters the Earth's atmosphere, blue light is scattered in all directions, creating a blue sky. In contrast, longer wavelength colors, such as red and yellow, are scattered less by the atmosphere. This is why the sun appears yellow or orange during sunrise and sunset, when the light has to pass through more of the Earth's atmosphere before reaching the observer. So, in summary, the sky appears blue because of the way that blue light is scattered by the Earth's atmosphere. This process is known as Rayleigh scattering and it is influenced by the size of the particles in the atmosphere and the wavelength of the light. 6. Why does the sky turn orange and red during sunrise and sunset? Have you ever wondered why the sky turns shades of orange and red during sunrise and sunset? It's a beautiful sight to see, but what causes it? The answer lies in the way that Earth's atmosphere scatters light. During the day, when the sun is high in the sky, its light has to travel through more of the atmosphere before it reaches us. This causes the blue light waves to scatter in all directions, making the sky appear blue. However, during sunrise and sunset, the angle of the sun is much lower, and its light has to travel through much more of the atmosphere before it reaches us. This causes more of the blue light waves to be scattered, leaving the longer waves of orange and red to dominate the sky. This is known as Rayleigh scattering. The colors we see during sunrise and sunset can also be affected by other factors, such as the amount of pollution or dust particles in the air. These particles can further scatter the light, creating even more vibrant colors. So, the next time you see a beautiful orange or red sky at sunset or sunrise, take a moment to appreciate the science behind it. It's a reminder of the intricate and fascinating ways in which our world works. 7. How do clouds affect the color of the sky? Have you ever noticed that the color of the sky changes when there are clouds? It's not just your imagination. Clouds can actually have a significant effect on the color of the sky. When the sky is clear and blue, it's because the Earth's atmosphere is scattering sunlight in all directions and blue light is scattered more than other colors. However, when clouds are present, they can scatter this blue light even further, leading to a lighter or more muted blue sky. Additionally, the thickness and height of the clouds can also have an impact on the color of the sky. Lower, thicker clouds can make the sky appear grayer or duller, while higher, thinner clouds can create a more vibrant and colorful sky. It's important to note that clouds can also reflect light from the sun, creating beautiful and colorful sunsets and sunrises. So, while clouds may have a temporary effect on the color of the sky, they can also contribute to some of the most stunning natural displays of color that we get to witness. 8. Why does the sky appear darker at higher altitudes? Have you ever noticed that when you look up at the sky from the ground, it appears blue, but as you climb higher in altitude, the sky appears to get darker? This phenomenon is known as the blue sky darkening effect, and is caused by the way in which our atmosphere scatters sunlight. As sunlight enters the Earth's atmosphere, it collides with gas molecules and tiny particles in the air. This collision causes the light to scatter in all directions, making the sky appear blue to us on the ground. However, as we climb higher in altitude, the amount of gas molecules and tiny particles in the air decreases. With fewer particles to scatter the sunlight, the sky appears darker to us. It's important to note that the blue sky darkening effect is not the same as the darkness of space. Even at high altitudes, we are still within the Earth's atmosphere and can see the blue color of the sky, albeit at a darker intensity. So, next time you're on a plane or mountaintop and notice the sky appears darker, you now know why. 9. How does air pollution affect the color of the sky? Air pollution can have a significant impact on the color of the sky. When there are high levels of pollution in the air, the sky can appear hazy and less blue. This is because pollution particles, such as soot and smoke, scatter sunlight in all directions, making it more difficult for blue light to reach our eyes. As a result, the sky can appear less blue and more gray or white. In addition to affecting the color of the sky, air pollution can also have other negative impacts on our health and the environment. High levels of pollution can cause respiratory problems, such as asthma and lung cancer, as well as damage to crops and ecosystems. It's important to take steps to reduce air pollution, such as using public transportation, carpooling, and reducing energy consumption in our homes and businesses. By working together to reduce pollution, we can help to protect our health and the environment, and ensure that the sky remains a beautiful shade of blue for generations to come. 10. Wrapping up and fun facts about the blue sky. To sum up, the blue color of the sky is due to the phenomenon of Rayleigh scattering. The molecules in the Earth's atmosphere scatter sunlight in all directions, and blue light is scattered more than other colors because it travels as shorter, smaller waves. This is why the sky appears blue during the day. However, did you know that the sky can also appear blue during sunrise or sunset? This is due to a different phenomenon called me scattering. During these times, the sunlight has to travel through more of the Earth's atmosphere to reach our eyes, causing more of the blue light to be scattered away, leaving behind softer shades of pink, orange, and red. Another interesting fact is that the sky on Mars appears reddish in color due to the presence of iron oxide rust in its atmosphere. On Uranus, the sky is blue, but it is due to the presence of methane gas in its atmosphere. In conclusion, the blue color of the sky is not just a simple phenomenon and is the result of a complex interplay of light and matter in the Earth's atmosphere. But understanding the science behind it can make us appreciate the beauty of the sky even more. We hope you enjoyed discovering the science behind why the sky is blue in our video. Many people may think they know the answer, but the true reason is often surprising. Understanding this concept can help you better comprehend the world around you and appreciate the beauty of the blue sky. We are fascinated by the wonders of science and can't wait to share more intriguing insights with you in the future.